In this video, we're going to start Unit 3, which is about similar triangles. Similar triangles. Now, the unit talks about trigonometry, so it's technically the science of triangles. However, this is the first part of it, similar triangles. I believe previously in, let's say, previous years, you were introduced to the concept of congruent triangles. So, two triangles will be congruent when all the sides are equal, or their sides are congruent or equal, and definitely all their angles are equal. So I would say probably, for example, this triangle here, A, B, and C, and this another triangle. Let's say M, N, and P. So those two triangles would be congruent if one side in the first triangle equals one side, a second side equals a second side, a third side equals a third side. Now those sorry, those triangles would be congruent if three sides in the first equals three sides in the second. Now consequently, so the angles here would be equal. Now we would call some angles like corresponding angles. So for example, I see that AB equals MN and AC equals MP. So by default, the angle M would be equal the angle A because it's included between two equal sides. This is how we know the corresponding angles. So for example, I know that this side equals that side, this side I mean, and that side equals those two. So definitely B here, the angle B is corresponding to the angle N because they are contained in equal sides. So let me say, for example, I know that P here, the angle uh, P equals angle C. And I know for sure that by default now angle A equals angle M. One thing we have to always be remember in any triangle is that the sum of angles is 180 degrees. So I would always say that, let's say the angle A plus angle B plus angle C as measurement, they would equal to 180 degrees. Similarly, M, N, and P, they would equal to 180 degrees. In other words, if the angle N here, for example, was 40, and the angle P here was, let's say, 60, I definitely can know the measurement of the angle M because the angle M would be the entire 180, the total 180 of the triangle, minus the 40 and minus the 60. So you take out those two angles from the 180 and then you get yourself the measurement of angle M. The measurement of angle M would be 80 degrees. Since I know that M equals A because I said those two triangles are congruent, then by default also angle A, for example, equals 80 degrees. Those are some key features of uh, sorry, congruent triangles. Now in this lesson we're not going to be talking about congruent triangles, however, we're going to be introducing the concept of similar triangles. Now we know when things are congruent, they are identical. Everything is the same, exactly the same. When things are similar, however, and similarity is a concept that is widely spread and was widely used all over the world. So when we talk about similar triangles now, first I want to remind you of one type of triangle here. I think you know this type of triangle where all three sides are equal. This is called an equilateral. So it's going to be called an equilateral triangle. The good thing about an equilateral triangle, let's say the side length here is 2, so this is 2 centimeters and this is 2 centimeters. I know that if the triangle is equilateral, then all the angles are equal. Not only that, each angle would be, let's say the angle here is x, x would be equal to 180 divided by 3, which is 60 degrees. So each angle in the equilateral triangle is equal to 60 degrees. Now this triangle here is 2, 2, 2. Now let's try to draw a bigger equilateral triangle. Let's say that's an equilateral triangle, another one. I know that all sides are equal. Let's say they are 10 centimeters. I know for sure now all the angles again are 60. 60, 60. 60 degrees. Here, this is an equilateral triangle, a small one, and this is a bigger equilateral triangle. I can never say that those two triangles are congruent. However, I can say that those triangles are similar. They are similar. They look exactly the same. However, this one is like enlarged. So probably if you multiply all the sides or every side here by 5, every side in this triangle by 5, you get the new one. So this is the concept of similarity. Triangles would be similar if all the angles in one of the triangles are equal to all the angles in the other one. Now this is a particular case, but we can generalize it to general triangles. Now, so all those angles here are equal to those angles there. And let's say consequently, let me draw like a third one. Let's say, let me draw a third one here. This is a third equilateral triangle. So those sides are equal. Again, those three triangles are similar. It is as if we are looking, for example, at a map. So this is the figure on the map, and this is the figure on real life, like in real life. So it is like a mini scale of that. If we say that the sides here are 10, let's say, I know that 10 divided by 2 is 5. This would be called the similarity ratio. In other words, the ratio that we need to multiply the small one, all the sides of the small one, to get the bigger one. So this is as if we are doing scales in like on a map or geography. We're trying to draw something which is huge and just try to get a mini scale of it. Let's take another example here. So again, a triangle here. Let's say A, B, and C. I know that the angle B equals to 30 and the angle A equals to, let's say, 70 degrees. I have another triangle here which is called M and P, such that P equals 30 and let's say M is 70. Now let's look for the third angle here. And remember, the sum of angles is 180. So if you add those two, you would get 100. So what is left from the 100? It's 80 degrees. So by default, this angle is 80. We didn't know that from before, but now we know it's 80 because we're given those two angles. Let's look at the other triangle here. 70, 30. So again, 70, 30. This is again by default by the same way. It is again 80 degrees. So if I'm gonna deduce something here, I would know that if only two angles, it is enough to know that two angles in one are equal to two angles in two, then by default the third would be equal to the third. Then I would say that to prove two triangles are similar, I need to find or prove that two angles in the first triangle are equal to two angles in the second, and this is called the AA property or AA theorem. AA means A refer to angle. Two A's means like two angles. So if two angles in the first triangle are equal to two angles in the second triangle, I would say that those two triangles are similar. They are not equal. For example, this side, if this side is 2, probably, let's say this side is 2, it would be proportional to that side because this side is between the 70 and 30, so it's going to be proportional to the side that is also between the 70 and 30. So probably this is, I don't know, let's say 8. I'm sorry, the figure is not to scale, but I'm just talking high now. Let's assume it's 8. What if I said that BC is 5, let's say? What side in this triangle corresponds to BC? I would go look between 30 and 80. Where's 30 and 80? 30 and 80. So this side corresponds to BC. Now, how would I get this side? Remember, if this was 2, this was 8. So we multiplied this by 4 to get 8. Then definitely, if this is 5, this would be 5 times 4. So 20. The ratio would hold. There's a ratio of 4 from here to here. Let's say that this side here was, no, let's say this side was 12. This is proportional to AC. If I'm going to find AC, remember, from here to here, like from the small, we multiply by 4. Then on the other way around, we divide by 4. So to get this side, then it is 12 divided by 4, then it is 3. Now I know for sure now there is one thing I need to share with you here, that 2, 3, 5 will not be a triangle. I'm going to give you this property later on, because 2 plus 3 equal 5, so they would form a line. But now those are the numbers that I came up with just for illustration purposes. So I don't want someone tell me later, oh hey sir, 2, 3, 5 will never make a triangle because the sum of those two is equal to 5. But now I'm only giving those numbers for illustration purposes. That would be the end of this video. It was a bit long, but we will have other videos again to complete the session. Thank you for watching.